you guys. I'm going to talk a little bit about actually a very small thread of work that a couple of groups that started from 2 or 3 years ago. At the time, so we start to see that neural network is getting more and more powerful, and it's actually expected that the neural network will be applied to basically everywhere that we are aware of. And the situation that we start here is more of the things that we're concerning about the deployment of the neural network basically to critical system. So the history is that about 2016, and people start looking into the verification by applying the formal verification to do safety verification for neural network. And then 1.5 years later, so because of course, safety verification things has limitations, and people start looking into how can we actually apply or extend the software engineering approach to do the job. Okay, so I'm just going to go through a little bit of things that I'm aware of. Okay, so this is more like that we put engineering efforts try to make AI or basically deep learning things safety. And I'm going to talk about what's the risk. Okay, so first of all, what's actually the risk that we observed when we are actually using deep learning. And then we are going to talk about what we are able to do right now. So I think that what we are able to do right now is quite limited, but it's better that we can see how we have been up to. And then afterwards, we will see that, okay, so since we have been up to here, and what will possibly be our next big step. Okay, so this is actually coming out of from the AI landscape that we try to capture. And I'm not going to cover everything. Okay, so I'm just talking about the things that I think maybe can be aligned with a few of the points here. Okay, and the more important is that probably I will just more focus on the verification and validation part. And for the other part, I'm going to mention it because as far as I know, so there isn't much effort or there isn't much successful efforts up to now. But I think that the community should start think about how to do this. Okay, so what's the basic risk case? So as far as we understand of the area of deep learning is that at least here are a few risks that for deep learning people for actually not deep learning, for verification for safe AI people to look at. The first one is basically robustness. I think that everyone knows it. Okay, so everyone knows that. Okay, so this is up to now for most of the verification testing things is working on robustness. So I think this is we're aware. And the second is called generalization. I think that this is basically one of the most important topic for machine learning, and they try to handle the generalization problem. But this is also our problems, our risk when we are trying to do the learning. And the other one is try to handle what's the understanding problem. Okay, so up to now, so what we do verification and we do testing, and the thing is that we are actually doing things just by looking at what the structure is. Okay, so and then we probably need to think about instead of looking at structure level, we probably need to think about what's the semantic level. Okay, and also there's more of an interaction risk. The problem here is that, okay, so in most of cases when we are talking about the autonomous system, and then the deep learning is not an end-to-end solution in most of cases. And then if this deep learning is happen to be, for example, the perception unit or the control unit, basically some of the components of the system, then there's some interaction between the risk from this component and the risk from the other component. Okay, so robustness, I think that everyone is familiar with. Okay, the idea is that, okay, so if you have an image or whatever the input is from sensor, okay, so and then if you do a little bit of manipulation on it, so it basically says that if you want to have robustness, which means that you shouldn't change your classification. Okay, and the risk is on the other hand. So if the classification is actually very subject to this kind of
perturbations, then you have problem. Okay, so the problem is also very well known, and I think John already mentioned the Tesla car, the Uber car, that kind of stuff. They all related to this kind of risk. Okay, so what's the generalization error? Generalization error basically say that, okay, so when we are actually train the neural network, and we train in when we are actually producing the model, okay, but we cannot expect that all the application of this neural network is used on the same scenarios that when it is trained. Okay, so we definitely expect that when you are trained on here, and expect that you probably is able to apply to somewhere else. Okay, so that's our general expectation, but unfortunately, this is right now is a big problem for deep learning, and also in terms of our verification, our testing. So what can we do about it? Okay, so can we quantify this kind of stuff in a more in a better way, instead of just using the test data set to do the job? Okay, so that's a lot of risks. So, and understanding is even more serious. It's more like that from humans' point of view. So when you are looking at this image, you expect to know that, okay, so this is something more important in the middle. Okay, it's go ahead or turn right. But maybe machine learning is classifying these things not by looking at the important part. They're probably looking at, for example, the background, for example, the circle there. So machine learning may mistakenly doing correct classification based on wrong message. Okay, and then if they get wrong message, which means that it's very risky that if they apply to somewhere else. Okay, so there are a lot of understanding problem, and we also notify the interaction, which I mentioned before. Okay, so let's here is a little bit of effort we have up to now. Okay, so we have verification things, and for verification there are basically 3 threads of efforts up to now. The first one is by using constraint solving. Okay, we put and the second one is by using approximation, and the last one is by using anytime. And for the software engineering side of efforts, it's relatively new. Okay, so up to now it's only just by using coverage metrics and test case generation. That's the efforts up to now. But on the other hand, so for all the verification, for all the testing, now it's focused on the it's focused on robustness. Think about that there are greater risk of something else. Okay. So here's a general idea of what constraint solving is doing. Okay, the basic idea is, okay, we have this model, we have this safety requirements, and what we basically do is that, okay, we translate them into formulas, and then here we got a very gigantic formulas and put in solver. Okay, so and then by using solver to solve the problem. But of course, I mean, up to now, the size of the model is very small. Okay, it's up to like 10K neurons. I think the best one is up to 10K neurons, which is very, very small. And this is basically trying to calculate a precise answer. And then the effort is coming, okay, so we cannot compute a precise answer in an efficient way, then we do approximation. Okay? Approximation, the idea is that, okay, we have this approximation, and this approximation propagates through layers. Okay, and by using this kind of idea, the size of the neurons can be scaled slightly better. Okay, maybe 10 times better than the previous approach. But still, it's not up to the industrial scale neural network. And then there's another approach, which basically is, the idea is that, okay, so we are not actually trying to achieve the goal immediately. Okay, so what we do is we start to have something and gradually improve the precision of the results. Okay, and by improving it, we need to have theoretical guarantee saying that, okay, this kind of improvements will eventually converge to the optimal. Okay, so it is actually theoretical guaranteed approach, but the problem is that you need to probably wait for quite a long time to get the precise result. These are actually the verification approach, and the software engineering approach is even easier. Okay, you just develop a few coverage metric. Okay, and we have a coverage metric, and we're using coverage metric as probably as guide to find test cases, and using test cases to generate to actually evaluate the performance of the neural network. So let's up to now for the software engineering approach. But this is only just a 1 year, very baby step for this kind of stuff. Okay, so I'm talking about these are basically the things has been going through for 2 or 3 years, starting from basically to 2017 up to now. It's more like 2 and 3 years. And as far as you can see, it's actually very preliminary, and I expect that a lot of things can be done. So the first thing is that in terms of specification and modeling, from formal method people, so this is something very critical. So you need to be able to specify the model. Okay, you need to have some language actually to specify what's the meaning of safety requirements. And up to now, we still haven't seen this kind of efforts, seen this kind of stuff coming up. Okay, and the community starts to think about, okay, so what's the meaning of specification? And a lot of people talking about, okay, specification just training data set. But then how to summarize information from the training data set, that's a question. Okay, so still a long way to go. And for this, a lot of efforts here on verification and validation. The problem is that right now, every verification approach is working on neuron level. Okay, working on neuron level is very detailed, and probably is not the right way to do. Okay, so we probably need to abstract some information from deep learning and learn that we need a level of abstraction, maybe from feature level, which make your approach more scalable. And the second thing is that we know that the neural network is a gigantic model, and a lot of verification approach is working because that we can decompose the model into smaller ones, no matter the model or requirement. If we can decompose them, which will make things much easier. Okay, so compositionality of the neural network, I think that is still something needs to work out. But I think that's probably verification people or software engineering people need to think about. And of course, as I said, right now the effort is on robustness. But I think that from that point of view, generalization or understanding is more important than robustness. Okay, so the effort should extend to the other safety risks instead of just focusing on the robustness. Okay, so, and then these are actually something that I think I'm probably, it's aligned with what John is think about, is that more of the process assurance and get the certification. Okay, so the thing is that there was a very successful line of research of trying to certify, for example, the aircraft software. Okay, they have a very rigorous development procedure. This procedure is not only just working on the final product, it's also working on the whole development procedures. So in the case of machine learning, we probably start to think about, okay, so we start thinking about what's the best way of doing data collection, and what's the best way of constructing model, and what's the parameters for training, and how long, how many episodes you need to do for training. All this kind of stuff. There should be some engineering way or disciplinary way of monitoring the development procedure of the deep learning. Okay, and these things we haven't known how to do it, and I think that's something for the engineering community to think about this. And also the good thing is that we need to think about how to do the assurance case, which means that right now a lot of things is just to try to break stuff. Okay, so this neural network has this adversarial example. This thing has something wrong, but learn what do we mean by right. Okay, we start to think about assurance case, how to argue that these things is actually correct. Okay? There are ways to do this by probably extending what's the existing efforts on argument stuff. But let's see how it can go. And also, of course, I mean, for this runtime monitoring, because if the motivation of doing this is that if the verification is difficult, okay, so can we just monitor the behavior using an envelope of doing this thing? That's one motivation. The other motivation is that even if you verified, okay, there's a potential that there probably have runtime failure during the operation. So no matter if you verify it or not, I think the runtime verification is still something that we probably need to look at. And also, of course, we have yesterday have federated learning, that kind of stuff. I think with more and more involved model, okay, so there are more risks that we need to think about. For example, the security risk is probably stepping in. Okay? So a lot more things I believe that the communities think about, but up to now, because of course this is more of a very short-term research effort, and it probably just involved like 4 or 5 group of people up to now working on this stuff. So all these things is actually preliminary, but I think that in terms of engineering side of efforts or doing AI safety, I would say it could be quite promising. Thank you.